Okay, proportional relationships. You guys know what a proportion is?
Yeah.
What is a proportion, would you say?
Like
How big something is or something?
no,
Like how balanced?
Yeah, you get closer, huh?
How equal it is?
In a rough way.
isn't it like
Maybe how big something is compared to something else, sort of. Let me ask you this. What you actually described is a ratio. You know what a ratio is, right? Oh, what is it? 42?
1 to 2?
Oh, 1 to 2. 1 over 2, right? It's like a fraction, looks like, doesn't it? So then what's a proportion? Not necessarily. All right. I knew you were all going to get it wrong, so this is all just a rhetorical exercise. So most kids confuse the two terms, proportion and ratio. So a ratio sounds like you know what it is. Number over number, right? Comparison of two things, measurements, quantities. A proportion is two equal ratios. Right? So let me just spell that out. Let's go to the notes page. Because they don't really lay that out perfectly clear here. So see note. Go over to page 9. Okay. So a ratio, kind of know what that is, right? That's a numerical comparison between two or more measurements, right? It's a numerical comparison between two or more measurements. Okay? And Tegan said something like 1 to 2, right? If two things are in the ratio of 1 to 2, one of them is twice the size of the other. Would you agree?
Isn't it one like one?
You could do it that way, right? We'd start it, so with the two dot thing, it doesn't lend itself to operating mathematically on it with the colon. So I prefer to write it as a fraction, right? Does anybody ever build, like, say, a model car or something like that when you're a kid? Okay. Like it's a replica of some real car, right? And it has something on the box that tells you about how big it is, doesn't it? With a colon in it, maybe. Like 1 to 30, right? What does that mean?
It's 3 times smaller.
Well, the real one would be 30 times bigger, right? This would be 1/30th of it, yeah? So it would take, if you built 30 of them, you have to line 30 of them up front to back to get the length, right? You'd have to stack 30 of them to get the actual height, and 30 wide to get the width, okay? So that's a ratio, 1 to 30. One of the real one is 30 times bigger than the scale one, right? Or and by the way, that's also called the scale, right? Scale factor. You've heard that term? Like the model car might be 1/10 scale. Yeah? Scale factor. It's also division, isn't it? Because isn't it one number over another? 1 divided by 10? Isn't it?
Yeah.
Is it also a fraction? Yeah. That's why I really don't prefer the version with the colon in it. Okay? So just, for example, right? Model car. You might see it as, I don't know, 1/10, whatever it is. Okay? Maybe they're smaller than that. Size, 1 to 10, like that. That's one way to write a ratio, right? So that means that the size of the model car to the real car equals 1/10. Right? 1 to 10. Or here's another example of a ratio. Could be numbers of things. For if you have a classroom, I don't know what it is in here, you have 10 boys and 5 girls in classroom. How many kids altogether in that classroom?
15.
Okay, so there's 15 students, yeah? Okay. What's the ratio then of boys to girls?
Half to one.
10 to 5. Right? But we usually put these ratios in lowest terms. So what would that be in lowest terms? Right? 5 to 1. Boys to girls in that class are 5 to 1. Yeah? What about this though? How about the ratio of boys to students altogether? 10 boys, and we know there's 15 total students, right?
So it's 3 to 2. No, maybe.
2 to 3, isn't it?
Yeah.
Divide them both by 5, lowest terms. So in other words, 2/3 of the class are boys. Okay? And you can do the girls, right? It's 5 to 15, which is 1/3, right? 1/3 of the class is girls. Okay? So these are all ratios, right? Let's talk about a proportion. What did I say it was? Yeah, 2 or more equal ratios. 2 or more equal ratios. All right, there'll be ratios connected with an equal sign, yeah? Okay? I guess technically these are proportions I wrote up here as they're written, aren't they? So you might see, let's see, 9/6 equaling 3/2. That's proportional, right? Are they both in the same ratio? So when you hear proportion, you just think they're in the same ratio, which is a single fraction, right? Same one. Have you ever seen this? Like some number out of 20 is equal to 3/2. Is that a proportion? Are those two equal ratios? So it's a proportion, right? So how do you figure out what x is here? Remember what you do here? Yeah, you remember cross multiplying? That's when you cross multiply, when you have two ratios that are equal, when you have a proportion, right? So you would work that out by cross multiplying. Okay, so you kind of get an idea? Proportional ratio don't mean the same thing, okay? A lot of kids confuse that. A ratio is like one single fraction, one number compared to another number on the bottom. And a proportion is what?
2.
2 or more sometimes equal ratios. Most of the time we'll work with 2. It's easier. Okay? Everybody got this? All right, let's go back. And it's also a scale factor, isn't it? I told you, like the model car, 1/30th scale. I mean, there's 1/30th the size, yeah? 1/30. Okay? Well, instead of 1/30, we could think of our proportional relationships, with any two numbers that we don't know right now. So we could use x and y, couldn't we? Okay? So if we have two variables and they're proportional, right, then we can say that y/x is some constant number, right? And also what? What would be the same? Or what would not the same? What would also be constant, invalid? Well, let me ask you about the model car that's 1/30th the size. What label could you put on the real car then? As far as a ratio? 30/1. And that's just as valid, wouldn't you say? So how about this one here?
Y/x.
I could say y/x is also valid. or X over Y, because it has Y over X, yeah. X over Y. Right, it depends on from which perspective, right? If you're looking at the model car, it's 1 over 30, but if you're standing looking at the real one, it's 30 to 1 over 1, right? 30 times bigger. Okay. Let's look at exercise 1. Local farm stand. You can buy 6 apples for $4. Does that sound like a ratio to you? Yeah? Dollars per apple, or apples per dollar, right? Could write it the other way. So determine how much it would cost to buy the following amounts of apples. So if every 6 apples costs $4, right? Maybe I'll set this up because they want the cost, right? So maybe I'm going to set up a ratio as dollars to apples. Okay? So what's the original ratio that they gave us? Okay? Now I want to encourage you to all write like this, right? Because if I set up a proportion and I get one of them switched the other way, you're going to be horribly wrong. So when I set up this proportion, it's going to look like that, right? And to keep track of what needs to go top and bottom, I like to write this. So $4 to 6 apples, right? And they want to know the cost, dollars, to buy how many apples? 12. And I don't, so X over 12, right? You guys know how to cross multiply, yeah? So what is 6 times X? Equals 4 times 12. 48. Divide both sides by 6, and what do you get? Do we have to do both, show both sides divided by 6 anymore? You guys get that? Huh? $8. Everybody agree? So a dozen apples will cost you $8 because it's going to be in the same ratio as 6 apples. Which makes sense. You're probably going to work that out in your head, right? Because it's a simple one. Yeah? If 6 of them cost you 4, and twice that would cost you 8. Yeah, that's why I said do we need to show that? We divided both sides by 6. I would normally write over 6, but I'm thinking we're sort of all on board with that, right? Okay. How about 20 apples? Again, I want you guys to do this, right? Dollars over apples here. And then I want you all to do your proportion. All of you right now solve that. Let's see what you got. You do 4 over 6 equals what over what? X over 20. And you cross multiplied 6x equals 80. And so then x, when you divide both sides by 6, was what? $13.33. Yeah? What did you get? That's decimal.
Did you do 80 divided by 6? Yeah.
Or did you do 6 divided by 80? The other way. All right. Let's move on to part C. So on this one it says if C is the total cost, C for cost, for apples, and N is the number of apples, I want us to write a proportional relationship between C and N. Okay? Well, this is going to be the same thing that we did twice just now, right? Except instead of any number of apples, we have letters, variables for it, right? So we're still going to do dollars to apples. And it's still what ratio? 4 to 6, right? Is going to equal what over what in this case? What is it? See, this is why I write this here. C cost dollars over N number of apples. Right? And they'd like us to solve this for what? Just like we did up top, right, for the cost. So cross multiply. What do we get? 6c equals 4n. And then what do? Divide by 2. Is that right? Divide by what? 6. Right? So c equals what, guys? Put that in lowest terms. 4 over 6 in lowest terms. Don't touch your calculator for that. Just freaking divide them both by 2. 2/3 n. Right? So it's exactly what we did up there. Except we can't do that actual last division part because we don't know the numbers, right? Okay? By the way, does this, like, any chance look like y equals mx plus b? Not in the least. If it did look like y equals mx plus b, what would be the value of b in that equation? So instead of y, we have a what here? Let's see. Instead of an x, we have a what? Oh, an x. So maybe it does look a little like mx plus b, right? What's the value of b if this were that type of equation? This would be, like if you had to write plus something here, what would you write? Plus what? I want to write plus something that doesn't change the value of it. What can you add to something that doesn't change it? Oh, okay, plus 0. So what's the value of b? Oh! So maybe you can think of this as b equaling 0. And what would the m equal in this case? 2/3. Rise over run? Yeah? Okay. Hey, actually, part D, now they want us to graph it, don't they? Okay. And notice this is all in the first quadrant, right? Because it's a real-life problem. Are we going to have any negative apples? Or negative dollars? All right. So let's look at the axis. What's the input axis? N. And what's the output? Cost, right? mx plus b. So what would be the initial cost at 0 apples? It better be what? Yeah, right. I'm not going to walk into a store and leave with my hands empty and have them charge me money for taking nothing from them, right? So 0. And what is the rise over run from there? So from here I go which way? Up to? Don't tell me over, right or left? Right, it's positive. 1, 2, 3, right? And I keep doing that, right? Up to 1, 2, 3. 1, 2, 1, 2, 3. Right? We got more than enough there to graph a line, don't we? You could use your straight edge. I'll use mine. Yeah, like that. Yeah. And I go from here right up through all those guys there. I guess I missed a little bit there. A little off. Yeah, that's maybe better. I don't know. Yes, ma'am. Don't ask. Pass is there. That's your answer. All right. So you guys, right, you graph stuff like this, mx plus b, just count on the rise and run to get your next points, right? All right. All right, let's look at E. Now they're using function notation, right? According to the graph, cost as a function of number of apples, right? So C of 15 apples is what? It'll be the thing after the, yeah, 10, and that'll be dollars, right? So this says 15 apples cost $10. So illustrate this on the graph. So let's go on, where do we go on the graph to find our 15? On this bottom axis, right? And we go all the way up to what? The graph, which is at 10. right there. So what does this mean? Like if we wrote this as this thing, like function form, so C as a function of n, the number of apples, equals 2/3 times n, right? And so if n is 15, I just do this, don't I? Right, so C of 15, let's verify. What's 15 divided by 3? Times 2. Hey, it is, right? So what does this mean? In the context of the problem, what does this mean? What's the 15 represent? And what's the 10 represent? So what does this mean that C of 15 equals 10? 15 apples cost $10. 15 apples cost $10. That's all it means. That's all we get at. Far so good. Some of this is a little bit of review, right? Okay. Let's go over to the next page and see what they got going on there. All right, next page. So it says, oh, Jenny. How fast can Jenny run, kids?
5 meters in 2 seconds.
5 meters in 2 seconds. Does that sound like a ratio of things?
5.
Yeah? So would this be, so 5 meters to 2 seconds, would it be valid to write 5 meters takes 2 seconds? Could I also write every 2 seconds she covers 5 meters? Are they both valid? Okay, so we could use either one of them in the calculation, right? We have to figure out which one to use most of the time, yeah? Okay. Then which of the following gives the distance D, right? She can run over a span of T seconds. Well, which one of those do they intend to be the input? D or T? Time is the input, and the output will be what? Distance, how far she runs, right? So, what would we write then for, say, like an equation? If distance is the output, distance equals what? What's the ratio we have? Okay.
2t.
What is it? Why is it 2t?
Plus the time is in seconds. At the top it says 2 seconds.
Let's try it this way. Maybe we'll try it this. I got a better idea. Let's set up a proportion. So we're talking about speed, which is in meters per second in this case. Okay. So let's write a proportion, and maybe when we cross multiply it, we'll get something that looks like one of those answers. All right. So what would I put here and here? One of these two, right? Which one? 5 over 2, right? It's going to equal what? D, distance over time, right? So now what do we do? Okay, what do we get when we cross multiply here? Yeah, but we want the, yeah, D is the output, right? Equals 5t. Okay. Divide both sides by 2, right? We get D equals what? 5/2 t. Right? Or if you calculate, it would be 2.5t, right? Yeah, it'd be choice 4, wouldn't it? Okay. You see how when I set up the proportion and cross multiplied, I got, you know, like a regular input-output equation, yeah? Okay. Let's go to exercise 2. One important proportional ratios. Yeah, that's what they say. Erica is driving at a constant rate. You're in the car riding with Tom Pop there. What do they measure their speed in? Miles over hours. Is that a ratio, kids? Sure is, isn't it? Okay, and we're using ratios and proportions, aren't we? Okay? All right, so if Erica, 120 miles in 2 hours. Well, that's not a unit rate, is it? How far will she travel in 3 hours? Let's set up her proportion. How far? So let's put miles over hours. 120 over 2 equals, should we use a D or next? Let's use a D for distance. D over what? In 3 hours, right? Yes. All right, let's cross multiply. Lay it on me.
2D.
2D. 3 times 120 is what? 360. Divide them both by 2, and what's the distance?
How do you know that which one to like?
What do you mean? Like when I get here?
Yeah.
I'm trying to solve for D.
Yeah, up there.
It's
or- Oh,
It's currently being multiplied by 2, and you can do that by dividing by 2. Okay? 180 miles in 3 hours. Okay.
For that one?
Yeah.
Could you have just done it like 120 divided by 2 and then multiplied that answer by 3?
Mm-hmm. That's another way. That's all valid. Yep. That's exactly right. So you would have gotten what? 60 equals D over 3, and then multiply both sides by 3. That would also work as well. Okay? So a lot of times in math, I think you're finding that there's more than one way to skin a badger, right? Or whatever it is you skin when you go home.
It's easy, so it's gonna be.
Sure. Yeah. More than one way to do that, isn't there?
I think that one would have made more sense.
Well, I'm not here to make sense. Anyway. Part B, write a proportional relationship between the distance D, so driver times travels, okay? So now it's just going to be like generically, not 3 hours, but sometime T, yeah? So again, we're going to set up miles over hours for our proportion. And still be 120 over 2, won't it? Equals what over what? I'm going to use small d. Usually, I'm going to use a small d. Right? D over T. And just like the one up above it there. Yeah, let's solve it for D. So her disk 2D equals 120T. And so you get D equals what? 60 times every hour in time. So in other words, she's traveling how fast? Miles an hour, right? Hey, if this is y equals mx plus b,
0.
what's the slope of the line? 60. So up 60 over 1 hour. Up 60 over 1 hour, right? Okay. So let's probably use that, let me see. Okay. What is the value of the proportionality constant? From back in the beginning. Well, actually, we just talked about it. It's right here. So it's a constant speed or multiple of 60 miles every single hour, right? So that constant, proportional constant, is 60 miles per hour, or mph. Okay, now part D. Let's use our equation over here. This guy, D equals 60t. How much time will it take for Erica to travel 150 miles? So we'll take our equation, and what do we do with that 150? Where does it go? and D equals 60T. 150 miles. Is that time? Okay, so we put the 150 in for what in our equation? The D. So what do I write? 150 equals, it's just the other stuff there. 60, is that just 60? All right, I thought maybe you guys saw a T there, right? Well, they want to know how much time, right? So what do we need to do here?
Divide by 60.
Divide both sides by 60. So we get T equals what? What's 150 divided by 60? Think people with button pushers. 2.5 hours. Well, they want us to graph D. I'm going to make it lowercase d. They'll use capital D for other stuff another time. Okay. So we're going to graph our D equals 60T, right? Again, is this like Y equals MX plus B? What does the M equal here? In this thing? 60. What is B, or the starting point? 0. Plus 0, right? There's no B there. All right, so we put our starting point where? 0. Now, what are we counting by here? I mean, on this axis. 20, 40, 60. So, yeah, 20, 40, 60, 80, right? 100, right? Okay. So M is actually 60 over 1, isn't it? Write anything over 1? So where do I go from here? Up 60. Careful. Over all, this is 1, right? Right? Isn't that up 60 over 1?
Yeah.
Okay. You could be done here. How many points to find a line? You got 2 points you can put your straight edge on? Yeah, what? You guys will learn that. 2 points to find a line, right? So, I mean, sometimes for accuracy's sake, you might want to put more than 2 on there, but generally that's technically all you need, right? And there you go. All right, so part F. What is the constant of proportionality from C? Where was it? 60. Represent about this graph. It's the graph's what? Yeah. It is the slope, yeah. Is the slope, otherwise known as what? Yeah, M, otherwise known as, in a real world problem, slope is what? Rate of change. Is miles per hour a rate of change? In other words, that rate of change is Erica's what? Speed. Which is distance over time, right? Okay? Have any questions on this? Just be good to ask if you did. Okay? All right. I want to at least start the notes for 4.2 because we've done a lot of this already. Remember unit conversion?
Yeah.
Now let me stop this video here.